In this video, we're going to be taking a look at the Creality Hi Combo with CFS, everything from the unboxing through the setup, all the way to a bunch of example prints. And I tried to select a good variety of designs that would demonstrate the ability of the Creality Hi in both single color mode as well as multicolor mode using the CFS. And I'm also going to take you through a bunch of tips to getting started with Creality Print 6.0 in multicolor printing. Now, if you're not familiar with the Creality Hi, it is the newest model from Creality that appears to be part of their next generation of printers using closed loop motors. Outside of the K2, this is the next model employing this technology, and it also has a larger build platform than what we're used to seeing in smaller models like the Ender 3, as well as the K1 series printers. So this one here is 260 by 260 in the XY and 300 millimeters tall. It also has a bunch of other features that you'd expect from a modern 3D printer these days, such as Wi-Fi, a onboard camera, integrated lighting, as well as advanced control functions like input shaping. And Creality has also improved the print bed. And if you look underneath, it appears to be a pretty thick piece of cast aluminum. So this whole package looks like a very new concept from Creality and not just an iteration of an older design. There's going to be a lot to get through in this video, so let's not waste any more time and let's get started. We'll begin with the unboxing of the brand new Creality Hi Combo Kit. And because it's the Combo Kit, both the CFS and the Creality Hi printer come in the same box. They're nicely packaged together, and you can start by fishing out some of the accessories tucked away in the foam at the sides of the CFS. And once you get below that, you'll find a piece of cardboard describing how you can unpack the rest of the printer. It's kind of like a big foam sandwich with a bunch of layers, and in one of those layers you'll find this bag with the quick start guide as well as some tools and accessories. You'll find other things like a sample roll of filament, the power cable, as well as a spool holder. Since this is the combo kit, I assume that this spool holder bracket and spool holder are intended for use if you're just running a single roll of filament. Safely tucked away in the foam, you'll also find the upper half of the printer, which contains the print head as well as the gantry, and of course then you'll find the base of the printer. And this will contain the print bed as well as most of the electronics. You'll also find the flex plate in there. Now we need to put all of these things together. We can start by dropping the flex plate onto the magnetic build platform, and there's some raised edges at the back that will help you line it up. Now we've got two pockets at the side of the base, and this is where the top half of our printer is going to mount to. And the stepper motors are going to slip into those pockets. You'll need to slide the print bed all of the way forward and bend the stepper motor wires up a little bit so that the top half of the printer can slide in without interfering with anything. It should look something like this, and the print head should be facing the front of the machine. Right above the stepper motors, there are mounting plates on the left and right hand side, and each of those plates has two holes. In our hardware kit, we have 4 of these M4 by 8 button head cap screws, and I'll be installing each of them until they are snug, but I won't tighten them down all of the way until I have all 4 screws in place. Now it should look something like this, and then we can grab the remaining 2 M3 by 8 socket head cap screws, and these are going to get installed on the back of the printer on those frame members. So we can flip the printer around and it'll be very easy to identify where these go. You'll see them here on the left and right hand side. And with these 2 screws, I'm going to take the same approach and get both of them in place before I fully tighten them down. Now we can move the print bed forward and remove some of the packaging tape, and we'll see a bunch of electrical connectors here. The 4-pin connectors will get plugged into the 4-pin receptacles, and there's one on the left and one on the right hand side. But on the left hand side, viewing from the back of the printer, you'll find one more connection, and this is a 3-pin connector that will fit into the 3-pin receptacle. Now we can take those wires and we can start to flatten them out. We can't leave them sticking up, otherwise they'll come into contact with the print bed. So we'll be able to tuck some of these wires down into the frame. Try not to pinch the wires or pull them out of the connectors too aggressively while you're doing this, and this will mostly get the wires out of the way. Now in your hardware kit, you'll find 2 of these gray plastic covers, and these will snap into place over top of these wires to just really ensure that they do not pop back up and ever come into contact with the moving print bed. No hardware is required to keep these in place. Up at the top of the printer, I am going to install the single spool holder bracket. You'll notice that there's a hole in the side of this bracket as well as a bunch of slots, and you'll also find this bracket here with a PTFE tube connector. and it fits directly into place inside of the larger spool holder bracket, and there is one more single screw in the hardware kit to attach these two pieces together. Next, we can attach the spool holder itself, and it simply just twists into the top of this bracket, and once you twist hard enough, it will lock itself into place. The bottom of the spool holder bracket has a locking clip, and it's the same profile as the top of the printer frame, and conveniently at the top of the frame, Creality has put a sticker that shows you exactly where to place this bracket. We can just snap that into place, and now it's mounted at the top. The accessory kit also comes with a short piece of PTFE tube, which we can connect to the PTFE tube connector in the spool holder bracket, and then to the top of the print head. These are both push lock fittings, so you just need to push that tube into place, and it will be held securely. Now at the back of the printer, we need to take care of some of the wiring. There's a wire harness coming out of the back of the printer, and it's got a large connector on the end, and it has a warning sticker on there not to unplug it while the power is on. We're going to plug this connector into the receptacle at the top rear of the gantry, and now we're going to create a very nice loop for this flat ribbon cable by installing it inside of the clips that are already mounted to the back of the printer frame. So you can see how I have this nice loop here, and the ribbon cable stays flat through the range of motion of the gantry. Now we can plug our printer in by using the power cable at the back of the Creality Hi frame. And finally, we can swivel out the touchscreen, remove the protective film, and tilt it up towards us so we can see it better. So now we'll walk through the initial printer setup, and if you guys have noticed, I haven't set the CFS up yet. We're going to do that a little later in the video. So right now we're just going to cover some single color printing at first. With the printer powered on, you'll be met with the Creality splash screen. We can select our language, and then we can agree to the privacy policy, which it seems like they make you scroll through a little bit before you can press OK. And we'll connect to our Wi-Fi network next. After that, we can select our time zone, and then you have the option of connecting to Creality Cloud. For now, I'm going to skip that. Now it's time for the printer to take over, and it's going to run through the self-check process. This process will take a little while, and it's going to run through a pretty extensive list of tests where it's going to test all of the motors as well as all of the heating elements, and it's also going to run through the vibration compensation, so the machine will make a bunch of very awkward and loud noises. Then we can familiarize ourselves with the user interface, and by clicking on the folder, this is where you're going to find all of the files to print. The next icon below that is the controls, where we control the movement of the printer as well as the material and the cooling fans. The gear icon is our settings, and there's quite a few options in here, but one of the most important things we need to check is which firmware we're running. By clicking on the printer firmware, it will check as long as you're connected to Wi-Fi if you're up to the latest firmware version, and if not, it should prompt you to update. In here, we can also access expert mode, where we control things like the Z offset, and there's options for the lights that are installed on the printer as well. We can turn those on and off, and we can access the CFS settings, and again, we'll connect the CFS later and we'll go through some of that. And finally, if we click on the little robot looking guy, we can access the help menu, where we can find links to things like the wiki as well as the online menu and a few other help resources. And before we go any further, I just want to point out that the single spool holder at the top of the printer is the same Creality twist lock spool holder that has fit many of the machines that have come before it. And that means that my Super Deluxe spool holder fits this Creality Hi printer as well. I'm going to put this upgrade in place, and that's just going to ensure that the single roll of filament that we're about to load up isn't going to drag on the regular spool holder, and it will turn nicely. Now, Creality sent me their RFID filament, and at the side of the Creality Hi is an RFID reader. And so this means even if you don't have the CFS, you can take an RFID spool, and the tag is located underneath of the Creality logo. You can tap that on the side of the printer will make a loud beeping noise acknowledging the tag's been read, and now you'll see that spool show up in the material menu. Now you can take that spool and you can install it onto the spool holder. The filament path is intended to loop towards the back of the machine, under the spool, and then into the PTFE tube holder at the front of the spool holder bracket. Then we can push that filament down into the print head, and there's a lever on the print head that you'll have to depress in order to force the filament past the tensioning mechanism and into the print head. In the material menu on the touchscreen, we can just click the extrude button, and this is going to start the process where the machine will take over and it will automatically load the filament for you, and there will be a small amount of purge produced. And if you're not using RFID filament, do not worry. You can always head into the material menu and you can manually edit the type of material. So it comes preloaded with a bunch of options such as generic brands. Of course, they're gonna have the Creality brand in there. You can select PLA, PETG, and many more, and you can change the colors. And finally, before we get going, the Creality Hi comes with a camera located on the right-hand side of the gantry, and you'll just have to move the cover to the side the same way you would with a privacy cover on a laptop screen. So now we can get into setting up our first print, and when I first received this machine, it was only supported in Creality Print 5.1, so that's the interface that you're going to see here. Later in this video, we'll switch over to Creality Print 6.0, but either way, it's more or less the same. So where you have the printer list in the top left-hand corner, you'll have to dive into that, add a printer, and find the Creality Hi, and then we can add our model. I've downloaded a Lego style Squid Game character. I'll link to that in the video description down below, and we'll start by printing his torso. For this model, I'm going to leave most of the print parameters as is. I'm going to just change the sparse infill pattern to triangles, and this is mostly just personal preference. Now this model does have some features that will require supports, so we'll be able to test those out in our first print, and I'm going to paint the supports onto the bottom where you'll find some of these recessed holes. After slicing the model, you'll see that it applied tree supports elsewhere in the model where I did not request them. So we can just hop into the support section and turn these supports onto tree manual, and that should remove those automatic supports. Now I did select tree, but it did seem to apply regular supports. Maybe this is just a little bug in Creality Print 5.1, but later on when we move to Creality 6.0, I noticed that this is no longer a problem. So we'll just ignore that for now and accept those supports. Next, I'll try to send this to the printer, but you'll see that we still have to establish a connection to the Creality Hi, so we can head into the device tab, and then we can just click on scan add, and as long as our computer is on the same network as the printer, it should find it. We can click on that, we can add it, and now when we click on print, you'll find the Creality Hi in the drop-down menu. I'll check off the print calibration option and then just click on print for a one-click print. I've noticed that the calibration procedure before a print starts takes an unusual amount of time on this Creality Hi. I'm not really sure why it takes so long, but maybe Creality can fix this in future firmware updates for this printer. But either way, once the print gets started, it runs very smoothly and the first layer went down really well. I did notice that it might be a touch too close, so in this case we can go back into our settings, go into those expert settings, click on the Z offset, and now we can make those adjustments. So there's various increments of Z offset that we can adjust the print head by. So in this case, I'll just bump it up a touch a little bit further away from the print bed, and this is going to give me an even better first layer on future prints. And as I do with every first print on a new machine, I keep a very close eye on the first print just to make sure that there's nothing unusual going on. And in this case, nothing at all seemed out of the ordinary, and I could quickly get the impression that this first print was going to turn out looking great. The quality of the outer walls was fantastic. I could barely see the layer lines at all. This is my first printer with closed loop motors on the X and Y axis, and if this is any indication of how well that technology works to improve part quality, then I'm very impressed with it right now. After removing the print from the flex plate, we can come in for a closer look, and hopefully you guys can see what I'm seeing, where the, again, wall quality is excellent. The only place that looks a little bit rough was the unsupported section at the top of these circles on the sides of these two pieces, but they were still well within the normal quality of my other printers, so I wasn't too upset by that. In the future, I could apply some supports to those regions. The top surface quality was extremely smooth, and the supported surface at the bottom of the part where there was the support material, that also looked quite good. So now that I was very impressed with the first print, I'm going to move on to some of the other parts in this model, and we have this hood. Now you can see here that this hood is a bit of an awkward shape. It seems that the designer intended to print it facing downwards and fill up the bottom with support, but I'm going to take a different approach here, and I'm going to try not to waste so much support material. I'm going to flip this hood upside down. I'm going to lower it past the bottom of the print bed and create a flat spot at the back of the hood. Now I can print this thing upside down and use no support material at all. That flat spot will now be located at the back of the hood, which isn't going to be very noticeable. When the print does finish though, you'll see all of these facets on the print, and this is not the fault of the Creality Hi. As you guys had noticed in the slicer, all of those facets were present. This was just part of the design that you can download, again, at the link in the video description down below. But otherwise, the printer replicated all of those facets, like I said, that were in the file, and the parts that were round came out looking nice and smooth. And at the end, when we go to assemble this model, we can test the dimensional accuracy and see if all of these parts can be successfully assembled. But otherwise, so far so good for the first two models. No print failures here. Then I moved on to a few more pieces in this set where we've got more parts that should be printed in red. And again, I'm continuing to use the Creality Hyper PLA in red. We've got parts here that have supports that had to be put onto the model itself, so they're not just touching the build plate. I was able to remove those supports, and then the stuff that's still stuck to the rest of the part, I can scrape off with a knife or a scraper, and those came off fairly easily. And as we're continuing to look at this part here, I just want to point out again that the wall quality appears to be exceptional on these parts, and I'm hoping this continues when I use other brands of filament as well, not just the Creality RFID filament. All of the print settings other than the infill are all of the factory settings in Creality Print 5.1 so far, and those supports are very easy to remove, and all of the supported faces look very good. Moving on to the next set of parts, we've got the arms of this character, and again, more supports were needed here on this model, and this is the one place where I did see that some of the settings for the supports possibly could be improved. So in this case, I'm noticing some marks on the model, and that is where I could perhaps increase the XY distance from the model in the support section. I've been using the standard layer height of 0.2 millimeters for all of these parts, and you can even see on these arms where they come into a sort of dome shape at the top. It's looking very nice, and it doesn't look too aggressively stepped. And so I'm going to continue on with these same settings for the remainder of the models, but it is time to change colors. So for that, we can hop into the material menu and simply press on the retract button. And now the printer will automatically cut the filament for you and retract it and release it from the print head. Now I'm going to remove the PTFE tube here so you can see how the filament has been cut, and I can simply just pull it away from the spool holder. And now I can load in some black Hyper PLA filament. Again, this has the RFID tag on it, so I can just tap that on the side of the printer. The printer will make that loud beeping noise, and the screen will switch over to the black filament. I'll run through the same filament loading process as previous, so I'll loop the filament around towards the back of the printer, push it through the PTFE tube, and then on the screen, once I have the filament inside of the print head, I can just click that extrude button. And if you watch very closely, when the new filament is loaded in, the red filament will be purged, and that little bit of purge, or what is also known as poop, will be ejected. And now we're ready to run with some black PLA. The next part to be printed is this Lego style head of this Squid Game character, and you'll see on the front of the face there are some very small 90-degree overhangs which are going to require support material, and for this I will enable supports. I'm going to be using tree support, and because these overhangs are so small, I'm going to reduce the top Z distance for the support material down to 0.2 millimeters, and I want to reduce the risk of the support material leaving marks on the print. So I'm going to also increase the support object XY distance from 0.35 millimeters to 0.5 millimeters, and that should hopefully move the support material away from the actual model so it doesn't leave any scars. This model here printed successfully on the first try, and as with the red filament, this is also Creality Hyper PLA, so I fully expected that this would also print very well. I thought the part quality was very good. However, the areas on the square symbol on the front of his head where I didn't apply any support, I thought those could be improved. So if I were to print this again, I would add support in that area. At the bottom of the head where the part flares out and upwards, it's a fairly aggressive overhang, and I thought in that section the part quality could be slightly better, which might indicate the part cooling could be improved slightly, but it was still very acceptable. Now we moved on to a few more parts here, and these ones were looking very good, but as the part got a little taller, I noticed a repeating pattern on this part, and I was wondering if perhaps the spool at the top of the machine shaking around might be impacting the part quality. Hopefully this goes away when we go to install the CFS and there isn't a spool shaking at the top of the frame. Considering the orientation of how these hands were printed on the print bed, I thought they turned out looking excellent. So far I've been very impressed with the quality of these surfaces that are touching the support material. So it seems like Creality has those settings dialed in very well. And now that we have all of the parts printed, we can go ahead and assemble this model. Now, I'm not the designer of this part, so I'm not entirely aware of the clearances that were built into this thing, but all of the parts did snap together extremely well, and I only had to tap a couple of the pieces with a hammer very lightly to get them to fit together properly. No glue was required for this model, and all of the limbs and joints articulate the exact way that you would expect from a Lego character. So this is a really cool model, and I'm very happy with how it turned out, and I'll put a link to it down in the video description below, as well as to all of the other models that will be featured in this video. Now, as you guys saw when I was printing these models, when I loaded in the different colors of filament, there is that purge that is produced, and that gets shot out of the side of the machine, and it tends to make a mess. So loaded onto the internal memory of the Creality Hi, Creality has included a few models, and one of them is this purge or poop deflector. So I've gone ahead and printed one of those in some Creality Hyper PLA in white. On the printer, you'll also find a file for a purge bucket, and it's pretty small. So I went ahead and designed a larger one because when we do get into the multicolored prints, you will find that the purge bucket will fill up very quickly if it's too small. I'll link to this design file in the video description down below so you can go ahead and print your own. And so here you can see that I've got it sliced and ready to print. And in this case, I'll just demonstrate that instead of clicking on the print button, which is a one-click print, I'll hit send, and that's going to send that file to the Creality Hi where we can access it in the file system. And on the touchscreen, we can just select that file and now click print. The poop deflector that I showed you earlier snaps onto the side of the gantry, and you can see here in slow motion that the purge that gets shot out the side hits that deflector and falls straight down. And in a moment, once we have our purge bucket printed, it will fall directly into this bin. And this should eliminate the mess that's created around the printer, keep things very neat and tidy, and it'll be a very easy bin to just slide on and off the side of the printer so that we can easily empty it when it inevitably fills up. We're finally ready to check out the CFS, which is the Creality Filament System. And this is one of the main components responsible for the color changing party trick that most of you are probably interested in and why you're here watching this video. It can hold up to 4 rolls of filament and has these compartments where it will hold some desiccant material in order to reduce the humidity inside of the box. It also has integrated RFID tag readers, so you're not having to tap the filament on the side of the machine, you can just insert it right into the CFS. And it also has these interesting little spring-loaded bumpers on the underside of the lid, and they come in contact with the edges of the spool, so when the spool is backfed, the filament cannot come off of the spool and get tangled. With the CFS kit, you'll also have this filament buffer, some extra PTFE tube, a few cable connectors, and inside of the bag with the cable connectors, we'll have the double-sided tape that we're going to be using to install the filament buffer on the side of the frame. We're going to be applying this tape to the opposite side of the spring-loaded tab, so we'll just cut some of this double-sided 3M tape to size, and we'll put it on the back of the filament buffer, peel off the backing, and now we can stick this thing directly onto the right-hand side of the Creality Hi. The filament buffer has 1 output port on the top and 4 input ports on the bottom. We'll point the 4 input ports pointing down, and we'll line up the top of the filament buffer with the end of the aluminum extrusion on the frame. When running the CFS, you're going to want to remove all of the components of the single spool holder. Now, right here, I'm only removing the PTFE tube, but I would completely remove that single spool holder bracket. The instruction manual tells you to use the longer PTFE tube from the print head to the filament buffer, but in this case, it just seems way too long. So I'm gonna be using a shorter piece of PTFE tube that came with the kit, and it's not gonna make any difference, and it's going to be way less likely to get tangled. You can push the PTFE tube into the output port of the filament buffer. The shell of the buffer is slightly see-through, so you can see how far that tube is engaged, and you wanna get that thing all of the way down into the push fitting of that spring-loaded mechanism. Then the other side will just go to the print head, and on the bottom of the filament buffer, I'm just going to install the other PTFE tube into this port pictured here, and then from there into the back of the CFS. If you can put your CFS close to your printer, I would recommend using both of these shorter PTFE tubes. From the CFS kit, we can now grab our electrical connectors. You'll notice that they are different. One of them has a right angle connector on the end, and the other one just has 2 straight connectors. So we're gonna grab the 2 straight connectors, plug one into the back of the left port on the CFS, and then we're gonna take the other end and plug that into the port on the right-hand side of the Creality Hi. The second cable with the right angle connector, it's shorter, and we're gonna take the straight connector and plug that into the right-hand side port at the back of the CFS, and the right angle connector can now get plugged into the top port on the filament buffer. Power to the CFS is supplied through those electrical connectors from the Creality Hi printer, so as soon as you turn your printer on, the CFS automatically turns on as well. The screen on the front of the CFS gives us a readout of the temperature inside of the box, as well as a measure of the relative humidity. And with the CFS now connected to our printer, we can head into the settings on our printer touchscreen, check out the firmware section, and it will give us a reading of the CFS firmware, and we can check for updates. So that's how quick and easy it is to get the CFS set up. And again, you'll notice here that I've removed the single spool holder from the top of the printer. This is critical because we do not want that PTFE tube getting caught on it. We're now ready to install some filament, so I'm gonna go back and grab the RFID Hyper PLA from Creality. I'll just simply place it in the CFS, feed it into one of the input tubes there. The CFS will grab that filament and feed it in, and the RFID tag reader will do its magic and read the tag on that filament. Now you'll notice in the second slot, I'm putting in a non-RFID spool, and I'm gonna show you guys how to deal with those. So back at the printer touchscreen, we can go back into the material section, and now with the CFS connected, you can see the 4 spools. And because the second one does not have an RFID tag, it's got the question mark. So we can click on that, we can click on edit, and now we can adjust the properties of the spool. So I'm gonna change the brand to generic. It is PLA, and I'm going to keep the color on gray. You can also make adjustments to the name and the nozzle temperature range, but for now, I'll just leave those as the default settings. Click OK, and now we're ready to slice up a multicolored print. To do that, we're gonna hop back into Creality Print Slicer, but this time I've got Creality Print 6.0 because now it supports the Creality Hi. So I have to re-add the printer. I'll select it from the printer list, and at the time of this video, you guys can see that it's in the CR Series tab. And the first multicolored print that I'm going to import is a Hueforged model. So I'm gonna add this in, and you can see it's currently just one single color. I'll put a link to this model in the video description down below, but the creator of the model had very specific layer height settings, so I'm gonna go ahead and change those over on the right hand side. So the layer height will be 0.08 millimeters, and the first layer height will be 0.16 millimeters. In the top right hand corner of the screen, we have a bunch of buttons that are all related to the CFS, and so I'm gonna click this button here and add several different colors of filament. You can click on each filament placeholder, and that will take you to a color palette where you can select the colors of filament that you want to build into your model. And in this case, this Hueforged model will require some black, gray, white, and red filament. On the left-hand side, I can click on the Objects tab, and now I can right-click on the single object, and we can enter into the height range modifier. On the right-hand side, you'll see the first modifier appear, and we'll be following the height range settings that were outlined by the creator of this model. Once I've got the range back on the left-hand side, I can click on the number 1 representing the first filament position, which is black. I can change that to any other color that I want. So I could switch between black, gray, white, or red. And I can also do that just by clicking on the height range and using the numbers on my keyboard, 1, 2, 3, 4, and that will switch to the corresponding color. So you'll see here that I've added 3 more height ranges for a total of 4, each one having its own unique color. And now when we go to slice this model, the preview will give us a more accurate depiction of what the Hueforged model should look like once it's painted by the printer. This model is 200mm wide by 200mm tall, and you can see its position comes awfully close to the Purge tower, so just keep an eye out for that and ensure that your model does not interfere with it. Now, if you're doing Hueforged models, one other setting that you might want to look at is the infill, and in this case I should have set it to 100%, so I'll go back into the print settings, I'll change it to 100, reslice the file, and over on the left hand side you can now see that this model will take about 4.5 hours to print and requires 3 filament changes. Before we send this off to the printer, I just want to point out a few more things in the slicer related to multicolor printing. So up in the top right hand corner, there's a few more buttons, as well as the ability to not only just change the color of the filament, but also change the type of filament. So in this case, I'm going to switch it from Hyper PLA to generic PLA, and that would be the gray color because I do not have gray Hyper PLA. There's also a button to change the flushing values, and that brings up a from to table. And this allows you to edit the flushing volumes to switch from one filament color to the other. For example, if you're switching from a dark color to a lighter color, you may want to flush more filament so you do not get filament bleed. But conversely, if you're going from a light color to a dark color, you may not need to flush as much. Now we'll hit the send print button, and this brings up the send to printer screen where we can select the Creality Hi. However, when I switch from Creality Print 5.1 to 6.0, it doesn't seem to be picking up the Creality Hi anymore, so I'll close out that window and head on up to the device tab. And you can see the Creality Hi is still there, and maybe it's not finding it because the IP address changed, and if this is the case, we can just go and click on Scan Add again, and it should scan the network and hopefully find the Creality Hi since it's definitely online. And you can see the IP address change, so I'm just going to go ahead and add that. And whether you have one or multiple printers on your network, it's probably a good idea to set static IPs on your machines. Now that we've reestablished the connection to the Creality Hi, we can click on the Details button, and this is going to bring up the control dashboard within the slicer, and you can see on the bottom right hand side, we've got all of the colors loaded into the CFS. So it looks like we're pretty much ready to go, and we can go back up to the Preview tab, and this is going to take us back to the sliced model, and everything in here looks good as well. So we should be able to now click on the Send Print button, and the Creality Hi will now appear in the drop-down menu. We'll go ahead and select that, and you can see the filament mapping and how it actually matches what we have in the slicer to what we have loaded in the CFS. But if it didn't match, this also gives you the opportunity to remap the filament. And to do that, all you need to do is just click on one of the arrows beside the filament positions in the CFS, so the one in the bottom row, and then you can see an option comes up where you can reassign a new color simply just by clicking on it, and it's really that easy. And finally, one other thing you might notice is that there is a button on the left-hand side of this screen that says Print Calibration, and that allows us to run the print calibration, such as the auto bed leveling, before the print starts. So I'll go ahead and select that. Then I'll press the Start Print button, and the file gets sent to the printer wirelessly, and once it's been successfully sent, it automatically takes you back to the Device tab. At this point, you can sit and patiently wait for your print to start, and while you're waiting to entertain yourself, in the bottom right hand corner, you can watch the nozzle and print bed temperatures rising. When the print is finally ready to start, the CFS will kick on and will load your first color of filament. Now this thing is pretty noisy, so don't be alarmed when you do hear that filament rolling around and the motors firing up. It will feed the filament through the tube, through the buffer, and into the print head where it will begin its first purge. But luckily we've got that nice big purge bucket, which again I'll link to in the video description down below to catch all of that purge, which is also commonly referred to as poop. The poop bucket will be essential for models later in this video that require many more filament changes than these Hueforged models. These ones here, as I showed you earlier in the slicer, only require a total of 3 color changes. And while this first CFS print is going down, I found it very interesting to watch the coordination of all the mechanical and electrical parts. It's almost like they're performing some sort of robotic dance, and after laying down many base layers of black PLA, it's finally time to change colors, and you can see the print head move all the way over to the right hand side where it begins by cutting the filament. Then the print head will move over to the left hand side of the machine where it will purge the remaining filament, and while that's happening, the CFS will retract the color that's currently loaded in. So we're going to remove black and we're going to start to run in the gray filament. So we'll now push that gray filament through all of the PTFE tubes, through the filament buffer, and directly into the print head. At which point it will purge more filament to push any remnants of black filament out, load in the gray, and finally, to make sure that the print head is properly primed with gray filament, it will deposit some of that gray filament onto the Purge tower and then get back to work on the main model. And as you can see, there's quite a few steps here into changing colors of filament, so you can imagine once we move on to more complicated models, this can take quite a while. But this is the beauty of why I love these Hueforged models, because there's only a total of 3 filament changes, so it really doesn't add that much more time to printing something like this, which when it comes out looks absolutely fantastic. And earlier I mentioned that this model is 200mm wide by 200mm tall, and that's not quite the entire print bed, but it's a fair share of it. And when we zoom in on that first layer, this thing almost looks like it's been molded. There's really only one spot close to this edge here that is showing any signs of a 3D printer nozzle going back and forth, but it's just really cool to see how consistent this first layer is across most of the print bed. So now it's time to move on to the next print, and I'm going to remove the red filament and load in a different color. In order to get this thing out of the CFS, there's a small lever in front of each roll of filament, so we can just press that lever and that's going to release the tension on each of the mini extruders that's driving all of those spools of filament. You can simply just pull the filament out. Now I'm going to swap in some green filament from the other guys, and to feed that in, we just guide the filament through the PTFE tube, and there must be a sensor in there because it seems to just grab onto the filament and start to run it through. Now, although that green filament does have an RFID tag on the spool, it is from another brand, and that means it's not going to get read by the CFS. So on the Creality Hi touchscreen, I can head into the material settings, select that roll, click on edit, and then I'll change that to generic filament and I'll change the color. Now, unfortunately, this inability to read RFID tags from other brands is not exclusive to Creality. As far as I'm aware, if you had a Bambu Lab printer and you were trying to read Creality RFID spools, it wouldn't be able to work in that direction either. There just doesn't seem to be a universal RFID tagging system for filament just yet. I really enjoyed how much the previous Hueforged print turned out of the first Italian plumber that I couldn't help but to print another Hueforged model of the second plumber, whose name happens to be trending these days. Now in reality, I was actually just more interested in seeing how well this printer would handle various brands of filament. But while we're here, one more thing I want to point out in the slicer is that if you load in a spool of filament that can't be read by the RFID tag reader, then once you go to slice it, it's going to show up with this blank placeholder in the CFS mapping, and you'll see that the start to print button is grayed out. Now just a moment ago at the end of the last print, I showed you guys how to enter in the filament settings on the Creality Hi touchscreen. So once you go and do that, and then you hop back into the start print menu here, you'll see that the green filament is loaded in from the CFS mapping, and we're able to successfully start the print. So it appears to be critical that you do manually set the filament properties if you do have a non-RFID spool. This second Hueforged print took roughly the same amount of time as the first to complete, and with only 3 filament color changes, it's no surprise that there was no issues getting this one done. It looked very nice in my opinion, and again, the idea behind this one was just to test another color of filament from another brand and making sure that it works very well inside of the CFS, so it seems like there's no issue using Bambu Lab filament inside of the Creality CFS either. Now it's time to move on to a more complicated multicolored model, and for this we're going to be swapping out the green filament for some gold. And I'll show you guys one more time how easy it is to do this. So I'll press that lever, remove the old filament, install the new filament into the 4th position on the CFS, and just simply feed the filament through. It will automatically get grabbed and loaded in. Now if you guys have worked with other multicolored printers before, you'll know that it's quite tedious within the slicer to fully paint a model. So another thing I wanted to test out here was what happens if I take a model from Bambu Lab Maker World, which has already been painted and there's already a 3MF file available, and just download that 3MF and drag it into Creality Print 6.0. What's going to happen? And as it turns out, the model gets imported fully colored, and that's going to save us a ton of time. Now, as you might expect, inside of the 3MF file, there was also some data related to the machine that this file was saved and originally set up for. So all we had to do was just change the printer back to the Creality Hi. Now, if I do want to edit any of the object painting, I can click on the Object tab, and then beside the number 4, which is representing the 4th filament position, there's an icon that allows you to bring up a menu to edit and repaint the model. You can select a different filament color as well as a different brush type, as well as changing the brush size. You can even section the model, and then of course you can paint directly onto the model and change anything that you desire. So in my opinion, this cross-compatibility of 3MF files that were saved for other multicolored machines opens up a huge world of possibilities. It makes our lives so much easier because now we can go to other websites which are huge repositories for 3D models, and we can just download those and work with them directly. And all of this is probably made possible due to the fact that slicers such as Bambu Studio as well as Creality Print are underpinned by a lot of the same open source slicer technology. So for this model, I'm going to leave all of the painting as is, and I'm only going to scale this model up. We'll set this model to 125% scale, and then we'll take a look at the model in general and just see where we might need some support material. It looks like this model in particular would benefit from some support material between his feet as well as underneath his beak. I'll head into the support tab, enable supports, and then I'll switch that over to tree manual supports. And then using the custom support tool at the top of the window, I can now paint on custom supports. And here I'll do exactly what I described, and I'll just use one of the brushes there to paint on support material underneath the beak, underneath his arms, hands, fins, whatever you want to call those, and between his feet. And before we move any further, I noticed that after importing this 3MF, we do have a 5th filament up in the top right-hand corner of the screen, so we can just click on the minus icon to remove that last color that we're not going to need. Now we're ready to slice this print and check out the result. And the first thing I noticed in the statistics on the left-hand side is that this print is going to take upwards of 17 hours, and it's going to require 437 color changes. And one other thing I noticed is that maybe it's just my screen resolution, or perhaps it's a bug in Creality Print 6.0, but in the column on the far right hand side of those statistics, there should be a total, which I can't see, and I can't seem to expand this menu either. So unfortunately, I can't see the numbers in that far right hand column, but regardless, I can see the other columns which outline how much of each material is going into the model, the support, as well as what's being flushed and what's going into the prime tower. Total material for this model will be 141 grams. And with that information, let's send it off to the Creality Hi and see what happens. Now, one other thing I want to point out is that after pressing send print, you can see in the filament mapping that we only have 3 filament colors in this particular model, and the order that I have in the CFS does not match the order of the filament in the slicer. However, it does seem like the slicer is able to somewhat intelligently match up the different filament positions based on perhaps the color. So I thought that was pretty cool and was worth pointing out. Sometimes it's these little details that make a big difference when it comes to the overall user experience. For this model, I set up a time-lapse camera to capture the entirety of this process because this was a very long print, and obviously I couldn't stand there all day and film it. Despite the plus-size purge bucket that I designed for this printer, I believe for this model I did have to empty it about 3 times throughout this entire print. And the other thing that I experienced was the estimated print time was not entirely accurate in the slicer. The original estimate was about 17.5 hours. I set up my time-lapse camera for 18 hours, but it took nearly 20 hours to complete this print. So that's why that time-lapse video was abruptly cut off. However, I was very excited when this print finally finished, and it seemed like the support material was fairly easy to get off. I did notice that on the front of the penguin's body, in the white section, there were some very small black blobs poking through. This was not the case of one color bleeding into the next, as they were not mixed together. They could have just been small deposits from the nozzle, but they were easy enough to pick off. The rest of the model looked very good. On the underside, where it was fully supported, there were some deposits of gold filament in the black area that, again, I could spend some more time picking off, but you generally won't see that once the penguin's standing up. The crocheted pattern on the penguin's body looked excellent. All of the detail was still there. None of that was lost. And I specifically chose this model because of those fine details, as well as the fact that there were going to be lots of transitions from black to white and white to black, and I didn't see any color bleeding between those 2 drastically different colors. Now that I felt confident with the multicolor performance of this machine, I decided that I was going to take on a slightly bigger project, and I was going to print something that required multiple parts. The first of which is this mushroom cap, which contains several bodies, and I'm going to change the filament colors in the filament list in the top right hand corner of the screen to match what I have loaded into the CFS right now. And I'll be utilizing white, black, red, and blue, which are all RFID filaments that Creality sent me for use with this machine. And then rather than having to repaint this model, because this is a multi-body part, in the object list on the left hand side, I can simply select each of these individual bodies and change the colors. If you're new to multicolor printing, within slicers, that is a massive advantage whenever you can find models with multi-body parts. This makes changing colors so much easier than a single part which you would have to manually repaint. Under the mushroom cap, you'll notice that there was a large unsupported area, which I've now painted using the fill tool. And then I'll just need to go back into the support section and enable the supports. And when I have large flat areas to support, I tend to fall back on the more traditional normal supports instead of using the tree supports. One more thing I want to point out here is that when you change the colors of filament in the filament list, it does not seem to manually recalculate those flushing values. So try and remember to press on that flushing button, and then inside of that menu, click on recalculate to get new values. And those flushing volumes are probably very conservative, and you could mess around with those, but that's kind of outside of the scope of this video. So for now, we'll be using all of the default values. One less complicated thing I want to talk about, which is a massive efficiency booster when it comes to both filament wasted through purge as well as time, is the approach of printing multiple copies of the same part all at once. So you'll notice in the statistics on the left-hand side, printing one of these parts requires 255 color changes. And the time to print one model is nearly 10 hours. And you can also see that there's a total of about 170 grams of filament just wasted to purge. But if we go back and add multiple instances of this exact same model, you'll quickly come to realize that printing more than one of the same model makes a lot of sense. And that's of course assuming that you need more than one of the same model. Adding a second instance here only adds about 2.5 hours to the total print time, and you can see that the number of color changes is the same at 255. We're also using the exact same amount of flushed filament at 170 grams. So if you were looking at this from a business perspective, you could start dividing some of these costs across two of the models. And of course, if we fit 3, the situation is even more favorable. 3 models comes in at about 15.5 hours. So if you recall, a single model was just about 10 and 3 is 15. So therefore, each of these individually comes down to about 5 hours. And that's a huge time saving per model with the same amount of waste divided over 3 of them. Therefore, if you're going to be doing multicolor printing and you need more than one of the same model, fit as many of them onto the build plate as possible in order to be as efficient as possible and reduce the most amount of waste. Now, I only needed one of these videos for this model, so yeah, I only printed one of them, but I thought it looked great. And again, I was trying to go for high contrast colors, so this blue into the white, I did not see any bleeding whatsoever between those colors. However, I did see a little bit of strange banding there, and that could have been from this transition from this very steep overhang into the rounded section of this mushroom cap. But overall, I thought the print still looked pretty good, and then even that large support section came off fairly easy with just a little bit of prying. At some point, I'd like to experiment with using different materials as support material. For example, I've heard that using PETG is a great way to support PLA, as the two materials don't stick together very well. And using a multicolor or multi-material solution like the CFS is a great way to achieve this, and that's perhaps something that I'll cover in a future video. Moving on to the next part in this small build, we're going to be slicing another multi-body part, and this time here, it's going to be red and white. This part will also require some custom supports, and using the support tool in Creality Print 6.0, I can slide the highlight overhang slider around a little bit, and this will help me identify where I might need some extra supports. I'll go ahead and paint those supports on using the brush, and then over in the menu on the right hand side, I'll use the support menu and I'll opt for the manual tree supports for this particular model. This print required 197 color changes, and the slicer estimated a roughly 7-hour print time. And after patiently waiting, the Creality Hi delivered a very nice looking part once again. Considering all of these steps required to change colors mid-print, and the fact that this was potentially happening hundreds of times per print, I was very impressed with the reliability and repeatability of the CFS up until this point, and I was feeling very confident with just firing off more prints on this machine. I quickly sliced and sent the other half of this model off to the Creality Hi to be processed, but this time around things didn't go as planned. According to the on-screen messaging, it appeared that something was clogged in the extruder and it was preventing me from finishing this print. I thought it would be a good idea to remove the PTFE tube from the top of the print head and then increase the nozzle temperature so that I could potentially push or pull on that filament to get rid of that clog. Now, I was able to get the filament out of the print head, and it did look like there was a piece of swollen filament at the end, which perhaps was contributing to that jam. But unfortunately, it seemed like the printer was still not happy, and one of its other sensors was setting off some kind of alarm. This time it was telling me something was wrong inside of the filament buffer, and I was finding that the on-screen prompts were causing a bit of confusion when it came to trying to troubleshoot this issue. And then when I'd press the buttons like OK or retry, the CFS was just pushing lots more filament out the end of the open PTFE tube, and I was having to cut that filament off. Then I tried putting the PTFE tube back into the print head, resuming the print, and still the CFS was not happy. At which point this series of errors turned into a doom loop where filament was just coming out everywhere, and I decided to terminate this print. Now, at the time of recording all of the voiceover for this video, this was the only failed print that I had with the CFS on the Creality Hi. After restarting the print and not changing any of the print parameters or the print profile, the second time around, this model went off without a hitch. So perhaps the first time with that print failure, there might have been some quality control issue with the diameter of the filament, where it was a bit too large and caused that clog, but I can't say for sure. After that, I printed various other parts of this model, and many of these were just single color prints. The CFS was still feeding the filament into the Creality Hi, but of course there were no filament color changes involved. The quality of all these parts looked very good. This particular model had a small thread up at the top. The overhang sections of those threads printed nicely without any supports, and these threads here interface with threads on that mushroom cap. These two parts assembled together very smooth without any sort of clearance issues, and truthfully I would have to print more technical parts to better comment on the accuracy of this printer. However, this was a good sign that those parts in particular fit together nicely. After a few more prints, it was time to assemble this model, and I was able to assemble all the parts simply with super glue as well as some hot glue. In the video description down below, I'll put a link to the designer of this model. Shout out to PLA in PA. He does a lot of amazing models like this, and I've printed many of them in some of my previous videos. They all assemble really well, and I would highly encourage you guys to go support other creators like him. So go check out that link in the video description down below. And if you're looking to support this channel, you'll notice that I'm using some tools here, such as a hobby knife and a small file set, and these come in part of a larger kit on my website, embracemaking.com. So you can get yourself some handy tools to help you clean up your prints. And I've also got hex screwdriver sets that are great for repairing or assembling your 3D printers. I also have some custom flex plates available specifically sized for the Creality Hi, and we'll take a look at those in a moment. In the meantime, let's finish up assembling this model and see what the final result looks like. Since the Creality Hi is a new machine, and as far as I can tell, the build platform size is not shared with any of the other Creality printers in their lineup, I thought it was a great idea to offer custom flex plates for this specific machine. If you head on over to my website, embracemaking.com, you'll find a variety of these micro texture plates. Each one has a unique pattern that will transfer to the first layer of your print. Each pattern is made from a different type of film, and some of these films are better compatible with certain materials. For example, if you've ever printed TPU on a PEI plate, you may run the risk of damaging the PEI surface. However, if you use one of the H1H or PET surfaces, then you'll have a much better time with TPU. And in this example that I'm showing you right now, this is simply just green PLA printed on that rainbow textured plate, and you can see how it transferred nicely to the first layer. Now each of these plates is double-sided, so the second side on all of these plates is a regular gold PEI textured surface. And I'm going to print the other half of one of these storage boxes on that gold textured PEI surface, and I've imported my logo as its own part, and then I'll take the other half of this storage box and I'll import it and align it with my logo. You can see that these are two separate bodies in the object part list, and I'll assign two different colors to these parts from the filament list. And at this point, if we slice this file, the two parts are separate, and when we go to take a look at the sliced result, you can see that there is an interference between the green and the tan part. In order to combine these two objects and to get the effect of a multicolored part, we can select them both in the object list, right-click them, and click on Assemble. And this time when we go to slice them, you can see that there's no longer any interference and we've successfully imparted this logo onto the surface of the box. However, we can change one more setting to make this logo look even better, and we can select only one wall on the first layer over in the print settings on the right hand side. And now when we go to reslice this, you can see how clean the logo looks. So that's just one more quick slicer tip for those of you guys looking to perhaps brand your own parts with your logo. I'll get this part now printed on the Creality Hi on top of the gold texture side of my custom flex plate. And although I had no adhesion issues with the flex plate that came with the Creality Hi, I do have a personal preference for the more coarse texture of some of these aftermarket plates. So again, if you're looking for these plates, I've got a bunch of them on my website, embracemaking.com, and I've got a variety of other cool stuff on there too that I think you'll be interested in. Go check that out. Overall, my experience with the Creality Hi was largely positive. However, there were a few things that I ran into along the way that I would like to see improved. And the first one was, if you recall earlier in the video, when I was running this machine in single color mode, I had the spool mounted to the top of the machine. And I think with the very fast accelerations, the spool was shaking a little bit and imparting some of those vibrations to the frame of this machine. And on taller prints, that caused some print artifacts as the print head moved up higher. Now this did go away once I had installed the CFS and I got the spool off the top of this machine. So just a heads up, if you are running it in single color mode, I'd look into taking that spool off the top and relocating it off of the machine for the best possible print quality. The second thing I'd like to see improved is some of the slicer settings. In Creality Print, I would say the default profiles are about 99% of the way there. One of the very small things that I noticed was with the support material being placed a little too close to the models. So manually you can change that in the support XY distance settings, but perhaps Creality should just change that and increase the value to about 0.5 millimeters from the default 0.35 millimeters. And the third thing is that eventually if you do have a problem mid-print and you run into something like an extruder jam, like I had that one time, the on-screen messaging could be improved. I found it very confusing what the printer was trying to tell me to do and interpret what it wanted to do next. For example, extrude more filament or retract it. I think Creality could build in some more logical steps to help troubleshoot the problem and get your print resumed properly. Obviously, this could be a big problem if it causes you to abort a very large and long print halfway through. Lastly, in Creality Print 6.0, I noticed that on some of the multicolored prints, the estimated print time was not all of that accurate. In some cases, the actual print took over an hour longer than what was originally quoted. Now, this obviously isn't critical, but for people like myself who are looking to perform time-lapse videos of some of their prints, this is a little bit annoying. Now on to the good stuff. In terms of interfacing with the printer, the Creality Hi was very easy to get started with, and even a beginner could figure it out with a small amount of time invested watching YouTube videos like this. Compatibility with other brands of filament was also very good, and while I only tested PLA with this printer so far, the default print profiles in Creality Print Slicer worked very well with other brands such as eSun and Bambu Lab. I had no issues with the part quality using those profiles. The Creality Hi doesn't seem too sensitive using those other brands. Now, obviously without the Creality RFID tag reader, you're not going to get the benefit of being able to automatically read those filaments. But either way, at least the print quality is still very good. Another big positive was the ability to import 3MF files that were set up for other printers, such as for Bambu Lab printers. And that is because Bambu Lab has been doing multicolored printing for a long time now. So if you go online and you find a nice multicolored print, chances are it's probably already going to be saved in a 3MF file and set up for one of their printers. And the ability to just take that file and drop it into Creality Print, where all of the color painting is preserved, is an amazing convenience, and it's going to make your life so much easier when you're looking for models already set up, ready to go and print. In terms of print quality, I had no complaints there either. There were no strange artifacts. I already mentioned earlier with the spool mounted on top, there was a slight issue, but with the CFS installed, that completely went away. First layers were very reliable and smooth, and with the CFS, I didn't notice any sort of color bleeding between colors, especially shifting from, let's say, a light to a dark color or vice versa. I also really like the form factor of the CFS, and unlike the oddly shaped AMS light that comes with the Bambu Lab A1, the simple box shape of the CFS is very convenient, and it's very easy to store around the printer, up on a shelf, perhaps above it, beside it, or below it. And speaking of the CFS, I found it to be very reliable. I did have one jam, but that was in the print head and it didn't really have to do with the CFS unit itself. And some of those prints that I showed you guys required close to 500 color changes in a single print, and I had no issues with that. So overall, a great new printer from Creality that is truly a new design and not just an iteration of an older machine. And if you guys are looking to pick up one of these things, I've got links in the video description down below. It's a great way to support this channel while shopping for this printer that you're already looking for anyways. But before going shopping online, just remember to disable the Honey browser extension before clicking on any of those affiliate links from your favorite creators. Honey does not find you the best price, and they will actually cookie stuff your browser without finding you the best discounts. So even if they find you 0 discounts, the moment you interact with that Honey browser extension, they put a cookie on your machine and they replace the one from me or any other of your favorite creators that led you to that product. They also work with many vendors behind the scenes to actually hide the best discounts from you in order for them to negotiate higher commissions for themselves. There's lots of videos about this online, so you can go check those out on YouTube. And with that public service announcement out of the way, thank you guys so much for sticking around to the end of this video and watching. Please consider subscribing if you really do appreciate and enjoy this in-depth content. I've got a lot more on the way.